Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, my name is Nadia Ramadhina S from 11 Natural Science 2. I'm from INSAN CENDEKIA SERPONG School. And today, I would like to tell you about the isomer from C7H16. Let's check it out. Now, I will tell you about the isomer from C7H16 throughout this presentation. I want to tell you what is isomer. Well, isomers are groups of molecules that have the same chemical formula but have different arrangement, structures, or configuration. Although they have the same compound formula and constitute atoms, isomers do not always have similar properties. Then, what is C7H16? There are three functional groups in organic compound, namely alkana, alkena, and alkuna. Looking at its molecular formula, C2H2N-2, C7H16 is a type of alkana. Alkana are saturated compounds that are organic compounds that only have a single bond between the carbon atoms in a molecule. As you can see in the picture. Then, how to found isomer in one chemical compound? There is a slight difference in making isomers for alkana, alkena, and alkuna. But because C7H16 is an alkana, I'll explain how to make an alkana isomer. First, make a straight chain. Second, move one methyl group or CH3 to become a branch chain. Third, move the branch to the center. Fourth, if possible, keep sliding to the middle. If not, take one more methyl group so that there are two branches. Fifth, slide one of the clusters. Sixth, if possible, continue to slide one or both groups. Continue to do the step above until you get all the isomers. 7. After all possibilities are written down, count all possible isomers. For the record, for low-level alkanes, the number of C atoms ranging from 4 to 7, the number of isomers can be calculated by the formula 1 plus 2 power of n min 4. We can try to find the number of isomers from C7H16 using the formula first. Then we will get 9 isomers. Now, as you can see in the picture, there are 9 isomers from C7H16. The first is this one. Can be seen, this is one of the simplest isomers because only a line is formed from component C and H. Then, why is the name heptane? When viewed from the main chain, there are 7 molecules, therefore called heptane. The second, like there is a branch in the second molecule from the right. Therefore, we call it 2-point methyl. Why methyl? It is because there is only one branch on the main chain. But how about the main chain? If we count the main chain, there are 6 molecules in the main chain. So, we call it 2-point methyl hexane. For the third one, there is one branch in the third molecule from the right. So, the name is 3-point methyl, and from the main chain, there are 6 molecules. So, the name is 3-point methyl hexane. The fourth and the fifth are the same. There are branches on the second molecule from the right, but in the fourth, there are branches in the third molecule. Meanwhile, in the fifth, there are branches in the fourth molecule. When viewed from the main chain, there are 5 molecules. So for the first, the name is 2.3 dimethyl pentane. Why dimethyl? Because there are 2 branches from the main chain. And the fifth is 2.4 dimethyl pentane. For the sixth, there are 2 branches on the second molecule from the right. So the name is 2.2 dimethyl pentane. All the 7, The shape is the same, but there are branches in third molecule, so the name is 3.3 dimethyl pentane. Then the 8. There are 2 sequential branches in the third molecule, so the name is 3-ethyl pentane. And finally, the 9th isomer. There are 2 branches in the second molecule from the right, while there is 1 branch in the second molecule from the left. So the name is 2.2.3 trimethyl. If we count the main chain of the most branches, then we will get the name 2.2.3 trimethyl butane. Now we can calculate a total of 9 isomers. That's all for me. Sorry if there is a mistakes. Assalamualaikum warahmatullahi wabarakatuh.